So I want it to be of high quality. I want it to be content where you don't say, oh, it's obviously been randomly designed because this level is unplayable. It's also a wonderful gameplay mechanic. Your roguelikes, moving through those spaces and having them regenerate through them. PCG does not excuse poor mechanics or bad designs, such as No Man's Sky. It just doesn't excuse that because my world is big. Okay, there's nothing to do in your world, but it's big. It's a tool, right? Like anything else in our development tool set, you need to apply it when it suits the needs of the situation. So where are those needs? Right? So a lot of games now, you have this kind of idea of tile sets, right? Especially in board games. A lot of people are here kind of more from the board game side than the digital games. And you have tiles that you place this, that there's a lot of tiling on this. It allows you to have a lot of repeated patterns of this. If I wanted to build this room, I could kind of chop it into little sections and, you know, we've got the floor here, okay, that's going to be this. The walls are pretty much the same, I can glue them together, so that saves space in terms of it, saves me memory, saves me on kind of storage for that. I just need to store the individual elements, and then I have to store where do the elements go to build it up. Gives me texture bases to work from. That saves on a lot of art, because I don't have to design everything freehand. I can build kind of these units and then glue them together. Allows us great expressive base for the connection, reduces memory. So tiles, yay. And we've known about tiles all the way back since the 17 to 1800s in Prussian Kriegsstil. Here is a bunch of suitably mustached Prussian generals looking over a games board here, basically the precursor of Warhammer and that. And so this gentleman here is going, no, 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 I can totally do that. And this guy's going, no, you can't. And this guy's going, let me check the rule sheet. Okay. So here it is, Kriegspiel, German war game. Okay. It was one of the first to kind of codified rule system, and it had a movable terrain board with n by n grid of squares with different types of terrain on it that you could play on. And one company, one of the first companies that made these kind of tables, that's one of them there, created a special purpose table where you could actually roll up your board. So you would roll basically big cubes, and depending on which side the cube came out, that would be slotted into the terrain for that. And they would use this for officer training primarily. Okay. Here's some more of it. You can see the tiles being slotted in. Here's kind of a better developed board than that. We see this also, here's zombies, building the city and putting the zombies on it. I can place down new tiles of the city. It gives me a random experience every time. It allows me to not really see what's going on. I have a fog of war available to me, so there's wonderful things out of that. Carcassonne, right? Basically, this whole game is laying of tiles and placing them. There's your tile stack out of that. Diablo. Diablo is a big giant tile set for that. So here's the Diablo creator. GameSpy asked him, other games have tried to do the randomly content generation without much success. Why is it that Diablo can make it work? And he says, randomness is hard to do. It's hard to make things look and feel random to a certain extent, and it's incredibly expensive, he says. So this is why I'm saying that it's a force multiplier when used well. So let's say you have a good-sized dungeon, use our dungeon's example, 12 to 15 rooms, maybe even a bit less. And so for that, you basically have to make 80-ish room tiles in order to make a one look random every time that you play through it. Okay, so lots of content that's required to do that. But once you have that, it then becomes easy to slot them together. Here is, so this level here, that's the tile set out of it. And you can also have other little units. You can have other tokens, set pieces, right? You can have the boss room. You can have the forbidden layer, right? But maybe you have to have, like, you know, it has to look this way or it has to feel this way for this scene. But the area up to it, you don't really care about. The player has to traverse through it and has to face some challenges. How it exactly looks, I'll let a generator do that. Tile size also allows us to define player skills and actions against this. So here's our little knight here, and he can shield bash up to 4 squares out, and here is the distance that that needs in the game. And visually, you can also put signifiers. So you notice here that there's like this repeated pattern along the wall. Even if you didn't have this guidelines, you can kind of sense where 4 squares is inside of that. So tile-based placement, you can see this in a naive tile placer, you would have something like this. Create a set of tiles with a number of connections or walls. Well, the map is not large enough, so do I want a big tension, small tension? Select a random tile, place into one of the 3 connection points. If no connection points, start over. I build too small. And that's our random generator. Here's our larger element tiles that we can use to glue those together. And here's how they look kind of in some of the later Diablos. So you can see here, that's tile A, that's tile A repeated, so even in this generation, here's the same level generated again. There's M from before, that little L block. There's A with this kind of like, I don't know, looks like a shaver there. Again, you can see A, there's M again. So all 3 of these levels are using the same element tiles, but have a different kind of look and feel to them. So you can get a lot more content out. If you had to replay through this game, or it was another area in the same game, you're not going, this looks just like the last one. Okay. So genetic programming is one way that we used to do this, evolutionary programming. So you have a population of tree representations of solutions to a problem. We call them chromosomes. It's kind of a cartoon version of biology. And it's manipulated by crossovers or mutations. Crossover combines some of one level and another level and glues them together. Mutation makes a small change in a single level. So each chromosome is assigned a fitness score. Our fitness score could be, this persona really likes it, or this persona really hates it. And it's based on the ability to solve our problem. And our problem, this is build a cool level, whatever cool level is. So we need a good definition of that. Chromosomes with a high fitness are selected to continue on to the next generation. And the process is repeated until either a threshold of time is reached. You have 5 minutes to build this level while I have my loading screen, or a chromosome with a specific level of fitness is found. I'm happy with this level at this point. Okay. So here's our chromosome as a tree. Each node in the tree is a tile, and child nodes are placed relative to the parent. And so the nice side effect of this sort of representation, too, is there's lots and lots and lots of pathfinding algorithms and other kind of search algorithms through levels that are utilized via tree structures or graph structures. And if you develop your level with this in mind, you can then easily play A star over it in these types of systems. Okay? So here's the results of some of our early work on this. So in this case, what we were trying to do is create a fitness that said keep short, tight, compacted groups of rooms, make hallways between them. A hallway is defined as a basic room connected to a basic room, and if there's up to 5 basic rooms, we give it more and more fitness. If it puts a hallway off to nowhere, it decreases fitness. I have to put at most 3 boss rooms, which are the highlighted ones. The 3 boss rooms have to be placed as far away as possible from the initial start point, which is this little square there, and that's basically what we told it to do in the fitness. And then we let it run, it placed a bunch of rooms, it would breathe for so long, and then we stopped. So after 2,000 generations with 500 max rooms, we ended up with a couple of levels that look like this. Okay, could we see those in a game? It's a little bit big, maybe, but you know, if I was doing a D&D game, that's reasonably well. Now, what if I wanted to get this done quickly? So this was given 30 seconds on an average PC. We were able to get 500 generations with 100 max rooms, and we ended up with something that looks like this. That's probably closer to a Diablo dungeon in terms of size and scope, with 3 bosses. Now, a lot of times, you don't want to have your boss rooms that close to each other. You want to have some path between them. So we made a small change to the fitness function, and we said increase the length between boss rooms. That you gain more fitness if you increase those lengths between those. And this is what we came up with. So I'm not even telling it, design a level that looks like X. I'm saying this is the rule of a level, this is the pieces you have, go. And this is what it's building. You can see I've got my 3 boss rooms, and I have long paths between them. Okay. Exactly. This is all of Skyrim or something like that, right? Okay. So again, 500 max rooms connected through that. Okay. We also had one with gating. Are you familiar with gating? You come to a boss. You have to defeat the boss to get to the next part of the level, or you have to get to a door with a key in order to get to the next part of the level. Or you walk through a hallway and the thing crashes down behind you, and then I walk forward. Right? You have to go this way. So gated levels with bosses. This is what we're able to come up with. So you can see our 3 colored regions. This is an example of a little bit of an evolutionary dead end in a way. So here we have one of our levels that's been kind of, this guy's rooms have kind of moved around this boss, so he can't build out. So this is kind of like it's like an evolutionary dead end. So sadly it didn't. When we ran it again, we ended up with something like that. So you can see that there is some sort of amount of similarity because of that tree cutting. There's a few things that we're working on to try to remove this problem from the generator. But you can see that just by changing a fitness function and a few other parameters, I can go from big size level, small size levels, levels with long paths between bosses, and gated levels. We're working on Hotline Miami right now. So we're trying to put some of these into actual games. These are probably closer and better for if you were going to start playing D&D tomorrow. And now we're trying to create Hotline Miami. So I want to get into actual games that are being played today. We've reverse engineered they had a level designer package. We've reverse engineered the files for that. So I can now directly do coding and then put it out in the same file format, and then bring it into the generator. So this is actually laying boxes either on top of or under another one, because Hotline Miami works off of a lot of interconnected rooms with doorways, so there's very limited sight lines for it. So we're working on kind of building those right now. Okay. So how does this bridge in with story? So you've seen a little bit of narrative here, right? That this is, you beat a boss, then you go into the rest of the boss level. How do we look at stories? Developers. So here, this is one of my favorite games as a child, was Super Mario Land 2, the 6 golden coins on Game Boy. I used to play this all the time. And here is Mario's